Math Analyzers. Welcome to your Chapter 9, Lesson 4 notes, all about sine, cosine, and tangent in the unit circle. Now, we already know that our trig ratios are sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite of adjacent. And we also just learned that in the unit circle, our coordinate points along the circle are actually equal to cosine of our angle and sine of our angle, as cosine is our x coordinate, sine is our y coordinate. And we had just talked about that in the previous lesson before our quiz. And where that comes from is how sine, of course, if this is my theta, is opposite over hypotenuse. Well, guess what? The hypotenuse in the unit circle is always going to be 1. So it's going to be your y distance over 1, or just your y. And how your cosine of theta, so if this is your theta, cosine is adjacent over hypotenuse. So it's your x distance over 1, which of course is just your x. So if I write those as the coordinate point, x comma y, it's cosine theta comma sine theta. Those are equivalent to each other in our unit circle, which is why those angle measures are so important to note, those specific angle measures, and then where we meet up on the edges of the unit circle all the way around the 360 degrees, or the 2 pi radians. Okay? But what we've failed to mention so far is the tangent ratio. So we really haven't talked about the tangent ratio yet. So where is the tangent ratio in all this? Well, the tangent ratio is opposite over adjacent. Okay? So we'll use the above diagram to conclude that since opposite over adjacent, here's the above diagram, opposite over adjacent is y over x, right? So that means tangent of our angle is going to be y over x, because y is the opposite side, x is the adjacent side from that particular angle, right? So if it's also the case that x is cosine theta and y is sine theta, then what we can conclude about tangent theta is that it is equal to sine theta over cosine theta. So the things we know so far about the comparison between our trig ratios and our points in our unit circle based on the angle measure of the angle in question. Sine theta is equal to your y coordinate. Cosine theta is equal to your x coordinate. And then that means tangent theta, since it's equal to y over x, is equal to sine theta over cosine theta. Okay? And that's how we're figuring out our tangent, right? Okay. So remember that the unit circle has a radius of 1, so r equals 1, right? And its center is at 0, 0. So if we take that equation, x squared plus y squared equals 1, that we've talked about previously, that's the equation of the unit circle, and we replace x and y with sine theta and cosine theta, what we get is known as the Pythagorean identity. Okay, so that's why I titled this section that. This is known as the Pythagorean identity because this is the Pythagorean theorem, right? A squared plus b squared equals c squared. C squared is 1 squared, which is 1, your hypotenuse side. We call this the Pythagorean identity because of the Pythagorean theorem being used here with our trig identities. Okay? What we're going to do, real quick, is we're just going to determine the sign of each of our ratios in each of the quadrants real quick, okay? So let's consider it this way. Sine, remember, is y. Cosine, remember, is x. So where are our y values positive? Well, our y values are positive when we're up here, right? So that's quadrants 1 and 2. So sine is positive in quadrants 1 and 2. Where are x values positive? Well, x values are positive here, right? X values are positive here and here. So that tells me that that's quadrants 1 and 4, for cosine. Okay. And then let's think about the tangent ratio. I mean, everyone's positive in quadrant 1, so I can keep that as a plus that I was going to draw anyway, right? But tangent is y over x. So actually, both of these would need to be negative in order to divide to be a positive, and that happens in quadrant 3. And in all the rest of the spots, everyone's negative. So everyone I haven't filled in yet is negative. So the way that we remember this, is all students take Collins. All students take Collins. All of our ratios are positive in the first quadrant. In the second quadrant, only sign is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So if you remember, all students take Collins, then you've got it down pat. Who is positive where? This is your who is positive in each of the quadrants. And then you know, based on the whoever is positive, the other ones are negative. Okay? So everyone's positive in quadrant 1, only sign in quadrant 2, only tangent in quadrant 3, only cosine in quadrant 4. Okay? And that has to do with all of the stuff that we have been looking at so far, which also means that when I look at these using my unit circle, these are exact values that I'm looking for. What I want to do is use these and the quadrant these angles are in to determine what they're equivalent to point-wise, right? So when we're talking about sine, we're talking about what are the y values of each of these coordinates. When we're talking about cosine, we're talking about what are the x values of each of these coordinates. And when we're talking about tangent, we're talking about what's y over x for each of these coordinates. Okay. And so that's what we want to kind of look at right now. So we're going to use our unit circle to kind of help us do this because we need to think about our angles in question while we're doing this. All right. You need to think about your angles in question. So let's use this sample unit circle up here to help us as we go through. Okay, we'll use this guy up here. So sine of 30, well, 30 reference angle is right here, right? And this is essentially a reference angle of 30, 45 probably, but close enough, right? So that means we're in quadrant 1. So that means we're going to be positive. Now, what's the sine of 30? Well, that's the 1/2, right? It's the y value of the 30 degrees. So it's a positive 1/2 right here. When you go to sine of 240, let's think about it. Here's 90 degrees. Here's 180. Here's 180. And here's 270. So 240 is in here. It's in quadrant 3. What's sine going to be? Negative. What's our reference angle? Right? Well, 240 minus 180 is 60. Our reference angle then is 60 degrees. That means it's going to be a negative radical 3 over 2 because that's going to be my y value here. Okay. Sine of 90, well, that's right on an axis, right? So this is the point 0, 1. And the y value is your sine, so sine of 90 is 1. And let's just check those real quick just to show you, because I'm doing sine right now, so I might as well start there and then kind of move into the other ones. Let me just make sure that I've got my mode correct. I do. Okay, good. Must be my other graphing calculator that my mode was wrong earlier today. So let's type in sine of 30. 0.5, 1/2. Let's type in sine of 240. Okay, reminder, it is negative, so that's a good start, right? But reminder that radical 3 over 2 is 0.866, right? So negative 0.866, negative radical 3 over 2. When we're asked exact values, we need to use the radical terms instead of the decimal terms, obviously. These are decimal equivalents, right? Rational approximations of our actual irrational numbers. Okay, so exact values, the radical needs to be involved. And then, of course, sine of 90 is going to be 1, as we know, because that's one of the points, one of the main 4 points around our unit circle on the outside. Okay, so now let's do the same with cosine, right? So we start with cosine of 180. Well, that's right here. And this, of course, this point is negative 1, 0. So that means that the cosine of 180 degrees is negative 1. And again, proof, because we're in degree mode, this is what's working, right? Now the cosine of 90, that's right here. That's your x value. That's going to be 0 because of where it's touching on the axes. It's an x value of 0. Cosine of 150, well, 150 is right in here. It's got a reference angle of 30 degrees, right? Because 180 minus 150 is 30 degrees would be here as the reference angle. So you consider, well, what's the x value of that, right? What's the x value of that? Well, the x value of a reference angle of 30 is radical 3 over 2. Okay, but because we're in the second quadrant, that's going to be a negative radical 3 over 2. Okay, so just a reminder, cosine of 150 gives me this negative 0.866. Okay, so again, and we already checked, we knew what that it was equivalent to. Now, tangent is y over x. So I want you to be real careful here, right? Tangent of 180, all the way right here, it's y over x. So it's 0 over negative 1, which of course is 0. Tangent of 150, you already know that the x value of this, which is the denominator, is negative radical 3 over 2. So we also need to know the y coordinate of that angle right here, that 150 that's right about here, has the reference angle of 30 degrees, right? Well, we know that if the x coordinate is radical 3 over 2, then the y coordinate is 1/2, because we know that those go interchangeably depending on if your reference angle is 30 degrees or 60 degrees. So to rationalize it, well, actually, just to get it not in fraction form, you multiply top and bottom by 2, and you realize that you end up with 1 over negative radical 3. And since that's not going to fly, we can't leave a radical in a denominator. We end up with, because we're in quadrant 2, it's negative, but we end up with negative radical 3 over 3. Okay, because we end up having to rationalize that because we had that x term with the negative radical 3 in our denominator. So just to show you, just to make sure we all know that, you know, tangent of 150, and I know in one of the first few lessons we did, when we entered these, we did the comparison. So radical 3 over, oops, I don't want to be under there. I want to be out. Over 3 gives me 0.577, right? So I was negative because 150 is in quadrant 2 and only sine is positive in quadrant 2. So I'm using these rules to help me make these determinations. Now, this is the one that's going to throw us. Are you ready for this? Tangent of 90. This happens twice. Think about 90. It's 0 over 0, 1 as the coordinate, right? But tangent is y over x, so it's 1 over 0. Can you divide by 0? Nope. There are 2 tangent areas that are undefined, and then any of your matching points with those, right? So 90 and 270 end up with an x value of 0 as those coordinates, which means that these are the spots that are undefined. we're going to need to know that when we start to put these on the coordinate plane and stretch these graphs out so they're actual function graphs that we can look at the change over x and the change in y. When x is 0 and that's the denominator, you can't have it. It's an undefined thing. And actually, I'm sure we've done this before. I'm pretty sure we did this in chapter 8. But when I type in the tangent of 90, it's telling me it's not allowed in the function because that's a domain error because it's undefined. Can't divide by 0. Okay, can't divide something into 0 groups. So that's where you're going to get the error message because it's undefined. A lot of stuff coming together here, guys. A lot of stuff coming together. So now what we really use this for is these a little bit more complex trig word problems, okay? So if we have an angle theta, the terminal side is in quadrant 2. So what I like to do when I hear these is I like to sketch. So here's quadrant 1, here's quadrant 2. So we say the angle has a terminal side in quadrant 2. Okay, so that's where it is. Okay, and that means that theta is right here because it's going to be this reference angle, right? So, okay, we know that theta, sine of theta is 3 over 5. Okay, so if I drop my altitude to create a right angle with my x-axis, then I know that sine of this opposite here is 3, hypotenuse is 5, I can figure out my other trig ratios based on this knowledge. Now, what I want you to remember, what I want you to keep in mind is in quadrant 2, only sine is positive. And look at our answer for it, 3 over 5. I know sine is positive, okay? I'm not being asked the angle measure that gives me this. I'm being asked the resulting cosine. So the first thing I would do so that I know this missing side over here is plug into the Pythagorean theorem. Hopefully by now you've already said to yourself, wait a minute, this is a 3, 4, 5 right triangle. It is. This is a Pythagorean triple, and this is where knowing the Pythagorean triples is really going to come in handy. So this side over here is 4. And that means that cosine of this theta is 4 over 5. So what I need to be careful of is what sine is cosine in quadrant 2, and it's negative. That's my answer. That's it. That's all I have to do. Okay. So all students take Collins. Everyone's positive, only sine's positive. So anything else I were trying to find here would be negative. Like if I want to find tangent of theta, I know my 3, 4, 5, it's just opposite over adjacent. So it's negative 3/4. Because it's tangent, it's got to be negative in quadrant 2. Okay? Angle alpha has a terminal ray that falls in the 4th quadrant. Okay, so your sketch, and it falls in the 4th quadrant. And cosine of alpha is 1/3. So I draw my altitude, drop my altitude to the x-axis. Here's angle alpha. Cosine of alpha is 1/3. So cosine is adjacent over hypotenuse. Determine the exact value of sine of alpha in simplest radical form. Notice this time I had to say simplest radical form because this is not a special right triangle. This is not a Pythagorean triple. So I'm going to have to plug these guys into the Pythagorean theorem to figure out what this missing side over here is. Right, 9 minus 1 is 8. And then I take the square root of both sides. We can ignore the negative because it's a side length, right? And so this is 2 radical 2. Because 8 is evenly divisible by 4. So the square root of 4 is 2. That's your coefficient out front. 4 divided by 2 is your leftover radical 2. So that's what x is. Now, if I know that x over here is 2 radical 2, and I know that I want the sine of this, that's opposite over hypotenuse, then sine of alpha is 2 radical 2 over 3. Now, let's consider fourth quadrant. Cosine is the only one positive, so that means negative radical 2 over 2 divided by 3. Notice simplest radical form, and I had to make sure it was negative. Let me just show you tangent. Also, tangent would be negative because I'm in quadrant 4 and only cosine is positive. Tangent is opposite over adjacent, right? So 2 radical 2 over 1. So that's just 2 radical 2, negative 2 radical 2, because we're in quadrant 4. So notice, so easy when you've got a 3, 4, 5 or a 5, 12, 13 or, an 8, 15, 17, like one of those will be so nice and easy. You'll have to use Pythagorean theorem otherwise. Okay, so we'll have to use Pythagorean theorem to find the missing side otherwise. If we're asked exact form or exact value, that means the radicals got to stay put, and we always use simplified radicals, and we always make sure we have a rational radical that we're using. So we never have a radical in a denominator. All right, so which of the following is not equal to sine of 270? So let me just draw this real quick. I do a lot of sketching when I do trig, and that's a really good idea. So notice with everything, I've kind of drawn a picture. That's what I do every time I'm solving trig questions. Okay, so 270 is down here, and my point down here is 0, -1, right? So sine of 270, that's my matching y value. Sine of 270 is equal to -1. So I got to find someone else who's equal to -1. Okay. Oh, wait, I got to find someone else who's not equal to -1. That makes a lot more sense to me. And the only reason I say that is because, well, cosine of 180, cosine is the x value. And over here, this is -1, 0. So this is equal to -1. So it's not choice 1. Sine of 90 is up here, and that's 0, 1, which means my y value is 1, and I'm making it negative. So there's another one that's equal to -1. So now let's take a peek at negative cosine 0. Well, here's 0. And cosine of 0 is 1, or excuse me, the point at 0 is 1, 0, right? The point at 0 degrees is 1, 0. The x value is 1, but I'm making it negative. There you go. Again, that's equal to -1. So hopefully choice 4 is it. Sine of 360, well, 360 is the same as 0 degrees as far as the point goes. So that means it's equal to 0. And that's got to be my correct answer. Watch. Sine of 270 is -1. And I'm finding who's not equal. Cosine of 180 is -1. Negative sine 90 is -1. Negative cosine 0 is -1. Sine 360 is 0. The only one that wasn't -1. Could I have done this entire problem on my graphing calculator instead of sketched it? Yup. Just throwing it out there. Using this information now that we know that tangent equivalent as well as we know our sine and our cosines, now we can use all of this stuff to come together and figure out questions like the last ones that we just did. That's the whole goal. That's where we've been trying to get to. Okay, so 2 new things that we learned today besides doing those last 3 problems that we just did. That tangent theta is equal to sine theta divided by cosine theta. So that's y over x. And we learned the Pythagorean identity, which is that sine squared theta plus cosine squared theta equals our radius squared, or in our case, 1. And that is going to be our Pythagorean identity that we use a lot later on. Okay. But those are some of the things we've just put together. So it's really cool how much of this is coming together with this unit circle. All right, guys, give those homework questions a try and contact me if you need anything at all. I am very, very happy to help you through this because it's a lot of fun. Okay? I will be seeing you very soon. Have a wonderful day, math analyzers.